So dot product, also known as scalar product. And the reason it's called a scalar product is because the answer will be a scalar, not a vector. So we've got two vectors, and I've written them in as a column vector. So x1, y1 and x2, y2. So dot, so it's the dot multiplication. So u dot v, simply you multiply the x's together and you multiply the y's together and add them. And there's your dot product. So the actual answer then, as I say, will be a scalar. It'll just be a number. So if I wanted to dot product these, and please note, it is different to multiplication. You can't just look at this and go, oh, that's all right, I'll just span first outside, inside, last, like I would with parentheses. No, it's dot product. So we multiply the x's together, we multiply the y's together, add them up, and for this one we get negative 22. Now some rules when we're doing the dot product. If one of those vectors is multiplied by a scalar, again, you could factorise the scalar. There's no problems with that. So you'd have that lambda and then work out the dot product. So it's up to you. You could work out the dot product of u v and then multiply it by the scalar, or you could multiply u by the scalar then do the dot product. It will give you the same answer. Now this one you can treat like algebra. And so you go a dot u plus a dot v. So in this case, I can do it. Why couldn't I do it with this one? Because here it was the components that I want to do it. Here I'm just saying, oh, this vector times that one, this vector. So that one we can use the rules of algebra. So a dot u plus a dot v. Yes, they commute. It's still multiplication, it's just a different type of multiplication. And so we can do that in any order. U dot v should give the same as v dot u. U dot u then, if you think about it, would give you x1 times x1. So x1 squared plus y1 squared. Now that turns out to be the magnitude squared. Because remember we said the magnitude was the square root of x squared plus y squared. So u dot u is always going to be the magnitude squared. And here we go. It turns out, yes, this would end up being different to 2 squares. So again, I can use the rules of our binomial products here because it's the vectors we're doing here, not the components like that example we had. So we do get u dot u minus v dot v, and u dot u would be the magnitude of u squared, v dot v would be the magnitude of v squared, so we get those the difference of those two. So here's a little picture. So we have the vector v, we have the vector u, then the diagonal there, if I was to create the parallelogram, would be head minus tail. So it's going to be u minus v, the way I've drawn it, when you see where the head is and where the tail is. Now, I'm going to play with the cosine rule to work out that angle. We know the cosine rule, the length or the magnitude. So u minus v squared equals u squared plus v squared minus it. Same cosine rule, that hasn't changed. So if we want to find the angle between two vectors, I could make cosine theta, eventually, the subject of all this. Now, u minus v squared would be the horizontal component squared, difference in the x values, plus the vertical component squared, difference in the y values. And then on the right-hand side, we know that magnitude of u squared will be x1 squared plus y1 squared, and then the magnitude of v would be x2 squared plus y2 squared. Okay, collecting some like terms, and now I can start bringing it together. On the left-hand side, you'll see we have negative 2 x1 x2 minus 2 y1 y2. On the right-hand side, we also have negative 2. Again, you've got to ask yourself why I did this. Why did I cancel the negatives, but not the 2? For some reason, I've left the 2 there. But on the left-hand side, if I do get rid of those negatives, I hope you can see there, we've got x1, x2 plus y1, y2. Well, that was u dot v. So I've turned that into u dot v. And on the right-hand side, the x1 squared plus the y1 squared. I know it seems a little strange, but essentially, I've put it back to where we started from. Oh yeah, sorry. So we've got that. Divide by the 2 now, I divide by the 2. So if we're again saying that u is x1, y1 and v is x2, y2, then we know that u dot v, remember we found out is magnitude of u times magnitude of v times cosine of theta. Theta will either be acute or obtuse. So we don't end up with reflex angles. So theta was representing the angle between the two vectors. So you're not going to get a reflex angle. Find to the nearest degree then the angle between these two vectors. Okay, remember A dot B we now know is magnitude of A times magnitude of B cosine theta. Here we go. This is where I rearrange it, just like the cosine rule. Cos theta is A dot B over magnitude of A, magnitude of B. So subbing all that in. Okay. A dot B would be 3 times 4 plus negative 2 times 1. Magnitude of A is the square root of 13. Magnitude of B is the square root of 17. So all of that works out to be 10 on root 221. So to the nearest degree, 48 degrees is the angle between those two vectors. So some consequences then of the dot product. If u dot v equals 0, then the two vectors must be perpendicular. Cos theta is A dot B over there. Well, if A dot B is 0, you're saying cos theta is 0, got to be 90 degrees. Remember, that means our components, our unit vectors, those two special ones, I and j. So I dot j would be the same as j dot I, because they can commute, but they must equal 0 then, because we said they were going to be perpendicular vectors. U dot v, if they end up being plus or minus magnitude of u times the magnitude of v. It means those vectors must be parallel. Cos theta is going to equal 1.
1 or negative.
Or negative 1. Either way, you're going to get 0 or pi, so they'll be in the same direction or opposite directions. Yeah. So they've got to be parallel. Okay. Now, turns out, then, if it is greater than 0, then two vectors must be heading in the same direction. So they're both going away from the origin or both going to the origin. If it's a negative, then they must be going in opposite directions. And I dot I will always equal j dot j, because remember they're unit vectors, and we said that was the magnitude squared. Well, the magnitude of a unit vector is 1. 1 squared is 1, so they will always equal 1. Alrighty, playtime.